people are aware that we're recording. Go ahead, Scott.
Thanks, Carlos. Hi, everybody. I'm Scott Surovich. I am actually out of Buffalo, New York. So it is not snowing yet. If anybody happens to want to ask that, it's usually the first question I get. Been around Kubernetes for about 7 years and running it in production, pretty big production environment that's global. I'm going to write to the book idea, though, Carlos, like you mentioned. And what it came down to, Mark and I saw that there were, you could find a blog on something, you could find a short little blurb on something, but it didn't really get into any of the details, right? And it's often a big overview and it's not secured. It just gets it running. And we couldn't find stuff. I remember when I was trying to start off about 7 years ago, I couldn't find anything to read. And it was very discouraging, right? Actually, how Mark and I got to know each other at one point too. I was looking for other geeks, like you were saying before, Carlos. I'm like, who else can I talk to? And he was on a podcast. So kind of met up that way. So he said, let's address some of these. And we come out with that first edition. And from there, it's just been pretty cool. I mean, you meet so many people in the community. We like the feedback. We like to hear what people are doing. So yeah, that's probably the short list for myself.
Okay. So it wasn't to get rich, I guess, right? People say,
no, that doesn't happen. I wish that would happen. But yeah, no.
I was looking this morning at the royalty that some book publishers give that juicy 28% of it. So yeah, great. So Mark, why spend time? Like you could be doing other stuff with kids. I know you have kids, right? And you can be at the lake. Why? How you convince your family that is to let you go and spend time writing?
I mean, you're assuming my family wants to be around me. The thing about this book that was a lot of fun and really I think is unique about this book is Scott and I come from very different backgrounds. Like I come from an applications development background. I come from the standpoint of I need to use Kubernetes to run something I need. Like I'm going to run things on Kubernetes. And whereas Scott comes from that systems management background. And so those two backgrounds coming together in this book really gives a unique perspective. Because there were times when we were going through the book where Scott would be like, I don't think I would ever do that in production. Like, oh yeah, you're kind of right. Or like, Scott, I can tell you right now, if you made me do this, I'd lose it. And so having those two different perspectives really brings unique aspect. The other thing that was really fun about this is we just integrate a ton of different technologies. Like one of the things that's very different about our approach on this book was, yes, we talk about Kubernetes and we get into the details of how Kubernetes works. But when we talk about enterprise and why it's the enterprise guide is because enterprises, you have to integrate with other stuff, right? You have to deal with silos. You have to deal with the fact that you don't own all the things that you need to be able to communicate. And so a lot of times when we look at different tutorials like, oh, run a database, run it on my, run it on your cluster. I'm like, well, I'm not allowed to run databases on my cluster. Run a vault, run a this, run a that, run it on your cluster. Like, well, no, my enterprise has this. I ain't got no choice. I gotta go integrate with that. How do I do that? What are the touch points? And so we spend a lot of time in the book talking about not just how Kubernetes works, but how you integrate with these other things. And so one of the goals was to say, let's say like in the secrets management, we use Vault. Let's say you want to use something besides Vault, right? You want to use, Pulumi's secret manager, a key list, whatever. All the concepts are going to translate, right? You're still going to use, decide, do I use a native sidecar? Do I use external secret operator? What are the trade-offs? How do I integrate that in? Like you still have to make all those decisions. And so that was a big goal of the book, was to be able to say, look, even if you're, this is not necessarily this is the stack you should build, but these are the things you have to think about integrating with. And that just, as a technologist, meant I got to play with everything. And so it made it a lot of fun.
That's great. So Scott, I think I missed it. Your role. I like the concept of Mark being like the user of the cluster kind of point of view, right? The app developer background, and then you're more of like the infrastructure of like, I need to provide the storage, the network, the compute to Mark to run. Like I didn't say Kubernetes on purpose, right? You're providing those things to these consumers and then teams, which it becomes kind of like thinking in terms of teams. Is that correct? I don't know if you mentioned your background.
Yeah,
Where
it
do you
is.
work right now?
I work at HSBC Bank.
Okay, and Mark
Global.
has,
So,
which is very heavy on compliance, security, right? And then
Yep.
Mark, his company, right? You
Yeah, so I'm the CTO of Tremolo Security. We're the makers of Open Unison.
So that's kind of, I think it's very important to in this book, and I from the chapter that I read is you drop some knowledge in this book about compliance. You mentioned NIST. I didn't see FIPS. Maybe you have it in another one, maybe in the Eastern one, or like on transit, or like, I don't know if you spell out HIPAA or PCI in the book. But those are the things when you go into production, right? Are another aspect of like, yeah, you can use X or Y, but then somebody asks you like, you need to prove SBOM, or you need to do FIPS, or you have to pass NIST, or you have to do PCI. Well, I cannot do PCI in this. I can do PCI in this cluster.
You know, where the compliance might come in, like why, so like especially in chapter 8, the one we're talking about today, with secrets management, where you're going to have to answer questions around the compliance framework. Which we get into it. I think we talk about it a little more also, like when we get to the last chapter. One of my favorite things I ever saw was Red Hat put together a compliance framework explainer for NIST 853 for OpenShift. So they went through all the different
Interesting.
controls that you have to fill out for NIST 853, and they said, this is how OpenShift covers it. And the thing I loved most about, beyond the fact that they did this, was when you got to the identity management controls, they said, this is not our problem. This is your problem. And so, what we wanted to be able to say in the book is be able to point out, hey, when you get to this part of the framework, you should recognize this is something you need to think about. So we don't dive into the specific frameworks, but just to know that, hey, these are things that people are going to ask you about and you're going to have to think about.
Yeah. So you need to have an answer and then show proof, right? Like, and sometimes these requirements are, say, continuously monitoring the usage of credentials, right? So that's the requirement that you mentioned, right? 53 is one of those requirements.
Yeah. So the way if you've never done a compliance audit, the way it works is you get a big spreadsheet, right? And every line in the spreadsheet is what's called a control. And so each control says, you have to do this thing. You have to show me proof you're doing this thing. If you're not doing the thing, you have to explain why and if there's a mitigation. And so, for instance, in NIST 853, there is a set of controls around identity and access, and it says you need to have a process in place to manage to say who has access to what. In this instance, I'm talking about credential management. You need to be able to say who's using a credential, how often are they using it, and how do you know if it's compromised? So a tool like Vault or any other secrets manager, one of the big benefits is the availability of monitoring who's actually pulling it out. right? Who's at, which systems are accessing. Set up correctly, you're using local identities, so you can say, no, I know that this pod accessed this secret at this time. And so then when the bad thing happens, because this is really the only time it matters is when the bad thing happens, they say, hey, this system got compromised. How do you know it wasn't because the password was embedded in your application? And we can say, well, it was not synced over here, or it was synced over there, or we reset it because we had to, and we saw that it got moved in. So that's where that's how the compliance framework system works. And when you're deploying an IT system that works with that framework, it's how do you go through that spreadsheet, and how do you apply that to your implementation?
That's very good knowledge. And in terms of secrets, I skipped on this chapter just to go over. I don't know if you want to drive the book, or I can drive sections that you want to go over, Mark. I think you're talking on mute.
Sorry, I'm in a cafeteria, so I don't know if there's a lot of background noise coming through. Yeah, I guess I could drive. This was actually a really fun chapter for me to write, for a couple of reasons. One is most people just don't do secrets right. People think that secret managers are for keeping things secret, and they're not. Right? Like, secret managers do not keep things secret. Secret managers make it easier to track secrets. First person I heard really articulate that was Kelsey Hightower was doing a demo of the Vault integration with Kubernetes to the SIG auth team. He was like, yeah, it's not about keeping it secret. I'm paraphrasing. It's not about keeping it secret. It's about knowing who's accessing the secret and being able to rotate.
Rotation, is that part of the NIST? I didn't ask, but is that part of the compliance of like proof that the secrets are being rotated, or they have X amount of time that you can tell, like what is the amount of time that secrets are good for?
I don't know that there's a specific control that says that. A lot of the controls don't get quite that deep. It might, but it's the from a cloud native perspective, a lot of people focus on, when it comes to secrets, the perceived security of the secret. So the first half of the chapter, we just talk about secret management and encryption. Like, we don't really get into a lot of tech. And as an example of why keeping things secret is not the important part, I talk about sealed secret. So being able to store a secret inside of a Git repository encrypted, and why it's one of the worst ideas out there.
Yeah, let's pause there. So I posted that in LinkedIn. Maybe that's why 30 people came here, because I put in LinkedIn this morning, quoted the book saying, "Sales secrets is an anti-pattern."
Yes,
right?
Absolutely.
And I'm not afraid to say it. And I say it to all my clients, because not because I read it, not because Mark said it in the book, is because I actually was in a big enterprise and people were using it. And the problems that Mark highlighted in the book actually happened. People forgot to put the tool things and then push the thing in Git. Another one is they deployed it with the certificate in the cluster. Guess what? The cluster got replaced. They no longer can decrypt all these secrets in Git. You can say that sales secrets is maybe a good idea, but in my book, anti-pattern.
Yeah, absolutely. I mean, and when you think about what Git was built to do, right? Git was built to make it very easy to share code, which is the exact opposite of what you want to do if something's a secret. You want to make sure that you can track where it's going. And so just a simple Git push, and oh no, I've now leaked all my secrets. And you say, well, but as long as you keep the key secrets, you're fine. Except the problem is as a species, we're absolutely terrible at that. We have yet to develop a technology that keeps keys secret for long. The best we can do is to be continuously changing it so that if there's a compromise, or really when there's a compromise, you're limiting the damage, you're limiting the potential blast radius. So any kind of sealed secret is an absolute anti-pattern.
And you even went far to put, I don't know if it was Scott or you, who was it that put this phrase of Benjamin Franklin. I was telling my wife, did Benjamin Franklin really talk about Kubernetes and secrets?
All
I
the
don't
time.
think.
Yeah. No, he's America's pioneer in
He was
Kubernetes.
ahead of his time.
So it wasn't enough to quote it. Put that seal secret was like you went far. But yeah, this is one about keeping secrets. And one question that I wanted to ask you is, and this is something that I deal a lot in my role is when I see people that are having secrets. One of the first things that I do, I ask them is like, do we need secrets? Because I'm not a fan of like having a hard code. Like for example, one simple example, we have this system called RDS, which is MySQL Postgres where I work. And I see the Kubernetes apps, and then they have secrets. And what is the secret? What's the username and password to the database? Like, where's the database running? Oh, it's a cloud resource. Why are you using it? Because that's one way that we connect, and the app works. Can we use something else that is ephemeral, that is a session, that is expiring, that is a two-way? Give me something for 1 minute and the app can rotate it, or something in the app can rotate it. I always go for like trying. I'm a person that goes into the environment and like, let's try to delete as much static secrets as possible, right? Even things of like asking vendors, if you use something like, I don't know, Stripe, or use an API, Stripe or AI API or something, like, can we ask that vendor to give me a way that I can give me a session that is good for 8 hours or 4 hours? Don't give me an API key that can leak. Like, even if it leaks, then it's good enough for 2 hours, or a login token that worked for 1 minute. I heard someone that it was like getting loves to get a login access that works, authentication that works for 1 minute to an EKS cluster. So what do you think about that approach as being the first thing of like, well, let's eliminate, if we work in an environment that is possible to not have a hard-coded secret, can we just eliminate it and then look for the ephemeral sessions, the ephemeral tokens, or a system that rotates, right? Even connecting to Vault, like, it's ephemeral. You get a token, but you don't get a hard-coded thing. What do you think about that approach?
Yeah, absolutely. I mean, you took the words right out of my mouth. And we talk about that a lot in the book. We point out in the book where you can do that, and all the examples we use try to use that approach. And in this chapter, when we do our integration with Vault, that is how we talk to Vault. So Vault is configured to validate the pod identity, right? So every pod gets a service account, assuming you don't turn it off.
This is what I'm showing here.
Yep.
The pod. Okay.
Exactly. So the pod, when it reaches out to Vault, using the Vault API, does so with an identity generated by the cluster. Now, you could extend this and say, well, maybe instead of it being generated by the cluster, it's generated by something like Spire, to be able to have a machine identity, right? That's generated by something besides just Kubernetes, because doing it with Kubernetes can have some issues to it. One of
So you're talking
them,
about the projected a projected token into the pod, like
Yep.
like we like this crowd is okay to talk about nerdy CKA level YAML, right? All I think every last week I asked, and most of people here are like are YAML engineers, I believe. So is what is a projected token that gets inserted based on how you configure the cluster. And that projected token can even be a cloud provider work identity, right? That
Yep.
then both needs to verify, is this pod the one running on this cluster on this cloud? Or if your Kube ADM, you're referring to the Kube API having both going back to the Kube API saying, hey, is this things created with the public key of this Kube API that I got, and that's the projected token? This is what you're talking about, the pod identity?
Yeah, exactly. So the you can tell a pod, hey, I want you to have an identity that's scoped to Vault, right? So every pod gets an identity that's scoped to the API server, unless you turn it off. But you can also say, hey, give me an identity that's scoped to this Vault thing. You send it over to Vault when you're going to go ahead and do a transaction. Vault's going to check to see if not only if the JWT is signed correctly and hasn't expired, but it'll validate that the pod is still running. So from 24 forward, every pod gets a unique JWT that is unique just to it. So if you drop a pod or if you drop a token from a pod that doesn't exist anymore, and you try to validate that against the API server, the API server is going to go, nope, no good anymore. So even if you have longer lived tokens, maybe the token's good for 8 hours, as an example. If you're recycling those pods, if you're refreshing them pretty constantly, that helps mitigate that risk of a long-lived token.
Why is that? Can you explain that again? Like, why? How does Vault knows that the pod doesn't exist?
Because Vault, so there are 2 ways you can validate a Kubernetes token. The first way is you can just treat it like a JWT. You can enable an issuer on your API server. So that's the OIDC discovery document. And you can tell Vault, hey, just treat this like OIDC. So like any other JWT, it'll get sent to Vault. Vault will check it against the public key, validate it, make sure it hasn't expired.
Yep.
Whatever other
That's when Vault doesn't have access to the cluster. Like cluster is on my house, right? For example, right. And I copy the CA, the files in the USB key. I'm dating myself, right? USB key, and I walk to the Vault and say, here are the public key that if somebody comes saying he was signed by this, you have the public key that you can verify it, right? That's the disconnected type of thing. And you say that there's a second one that Vault can go back to Kube API?
Right. So the second option is Vault knows about Kubernetes. So Vault can now this is the part that I wish Vault would change. You give Vault a service account, and so when the token comes in, Vault will call your API server and say, hey, can you please validate that this token is still okay? It's still kosher. And then the API server will say, yep, this pod is still running, or no, this pod was killed, don't accept it.
And that's the token review request that you're highlighting in the book?
Exactly. Now, unfortunately, Vault it would be better if you could tell Vault to trust you could tell Kubernetes to trust Vault, right? So you could have that 2-way trust with 0 static secrets. But unfortunately, Vault does not support that. Like, I can't tell Vault, hey, you need to be an issuer for this as part of this authentication method. And prior to Kubernetes 1.29, you couldn't have multiple issuers for OpenID Connect. Starting in 1.29, I think it went beta in 29. I think it went GA in 30. But I'd have to double check.
You sure that Kube API knows about, at least?
Yes.
Okay.
You could have multiple issuers. So
I can trust Vault because I have an issuer that, hey, Vault, you're talking to me, who you are, like double check against the issuer.
Exactly. So that way you can have no static.
So going a little bit further, you're saying that this system, right, works, but that means my Java application needs to read the token, and I'm talking to Vault to get my password for the database. But in most, not simple, that is you're going to write that code, right? That my Java application is going to do that. But the other way is, well, the Java guys don't want to put the library that talks to Vault that does the thing that, because it's an app that somebody wrote and left the company. That actually happens. And we just need to run it. So that's where Sidecar comes in, that it will do this dance, get the secret, and then put it in a folder. We'll talk about that in a minute. We'll put it in a folder for your app to read it. So the only thing that your app needs to do is read the secret from a file versus environment variables, which you mentioned is an anti-pattern. I think everybody agrees. But that pattern means, and you talk about it, that secret goes into a folder, but it doesn't go to etcd. And this folder that I mentioned is memory, right? It's a tmpfs memory. Is that correct? Is the empty
Scott, is
there?
it memory or is it scratched?
It
Got
it's in the overlay basically, because you're doing like a file for it. Now you said, Carlos, on one of those you mentioned the sidecar. That's just one option, right? There's a vault init as well, which
in
gets
the
you secret
container
just once. Yeah,
to
because
fetch it
if you do a
once.
sidecar, you might be hammering the vault server because it's looking to see if things were updated. Now, if you're rotating secrets, you definitely need that. And
So
Mark, keep me honest if you're talking about that.
that's
But
the requirement that I often see is, and the requirement is not that the client, and this one client, the requirement is not the client likes to rotate the secret every 8 hours. The client doesn't want to shut down the pod because they treat pods as VMs, and that pod needs to be running and running and running. And I asked them, how long is this pod running? Oh, for the last 30 days. A pod running for the last 30 days. How do you deal with secret? Oh, we have the sidecar that like gets the token every 8 hours, put it in a folder, and we read the folder. That's fine. Like, but how do you move the pods to do customization, to fail over? Like, oh no, we don't want to stop the pod. Like, that's not a VM. It's a pod. Like, yeah, but it's running our code. Is that resonates? Have you seen that use case?
oh, definitely in on my area. Secret. We were talking about this with service accounts and stuff like that. That there are, I'm going to say they are regulatory that you just can't have them, long lived. They have to be rotated. So that's a big push that I see, especially in my industry, right, in financial or even healthcare. So
Yeah,
yeah,
and
rotating them.
that what guarantees, like, because you can assume, oh, the pod gets deleted all the time, but that's not a guarantee, right? It depends when you're going to schedule or bin packing or consolidating. But um, I think you mentioned the use case correctly. For some regulatory reasons, you have to rotate it. So the only thing that guarantees is either your Java Go code doing the work, right, to rotate, to get it refresh the token, or the sidecar doing the helper thing. Um,
Yep. And there's also like I responded to you in the channel, but you get that file, and I know a lot of people think, cool, I'm in a vault, it's secure, right? Checkbox, all good. We're not using base 64 secrets. But what people forget is it's a file, right? So I can exec into the container and I can read that. So we can cover that in chapter 13. But it's one
yeah,
of my favorite use cases for runtime security is telling people your vault's not going to secure that once it's in the container. It can still be obtained.
yeah. And I think so you fall into the trap. That's what I wanted you to highlight. That is exactly the thing. Once you get that vault, that secret from vault over the wire with fix 140-3, right? Very secure over a transfer, right? Over the transfer, it goes to your that sidecar will put it into the file system, and then you'll be able to access it. So the next level will be like the code, right? The Java code will be like in memory, you get it, but still you need to secure your worker node, right? Anyone can go into the worker node, root, like mem dump, and then you have the stuff that is in memory, right? Nothing security over it's layering, right? Different ways of layering on what do you layer. But the file one is an interesting one, and I think Eric showed a demo of that once here. One of the podcasts. He's like, yeah, you can go into the system, find where's the layer, find the files, and boom, here's all the tokens. I can even take the token that got projected, right, and talk to Vault and get the other secrets that I didn't get, right, because I'm authorized to access different keys in that Vault, not just this one that is sitting here.
Yep. So you got to add an extra layer of like a runtime security and lock that down to just the process that needs to query the file. Not in this chapter, but it's in a future chapter on here.
So let's talk. Move on. Let's talk a little bit about external secrets. What is your experience on the field? You included into the book. External, like extra. Can you explain for folks maybe what is external secrets? What are the different backends that it supports, and then actually which ones you recommend or not recommend, or like which ones are like answer a lot of it depends, right? That's I think this is the good thing to have this kind of like podcast or book club.
Yeah, I mean, there are two ways you do secrets, right? You either have a sidecar, like we've been talking about, that injects it into the pod, or you use Kubernetes secrets, right? Like Kubernetes has a secrets API. Now, the big benefit of using the sidecar is that the secrets are never stored in the etcd database. The question is, does that matter? Like, is that a big deal? Is that a problem? Um, my argument is it's really not. Like, you know, or having the secret inside of etcd, I don't really see as that big of an issue when you actually sit down and you do your threat modeling. Uh, it's just, if you have access to the API server, whether you have access to the pod or you have access to the secret, you have access to the data. And I see that.
There's a hand up.
Yeah, Saifadine, am I saying that correctly?
Safe.
Yes, it's
Go ahead.
safe. Yes. Hi, Scott. I have a question regarding external secrets. I think it does matter because eventually it will create a secret in Kubernetes in etcd.
Yep.
Otherwise, why would I have like many hopes to have like external secret will eventually create a secret in etcd?
Yep.
So it's like why not directly creating a secret using the API, Kubernetes API? If I don't go directly to the application using the sidecar.
So if I understand what you're asking is what's the benefit of using an external secret operator as opposed to just generating the secret on your own?
Yes, exactly, because it
Okay.
will eventually create a secret.
Yeah, they all
That's a great
end
question.
up being in etcd. Yep.
Yeah. So that's a great question. So it gets back to what the value of a secret manager is. You could just write it to etcd if you're going to use external secret operator, but the question becomes, how are you generating that secret? How often are you generating it? Are you generating the metadata that's used for your compliance framework? Who has access to it? Who's managing it? So a secret operator allows you to offload all of that and say, hey, that's Vault's problem, right? I've got Vault configured so that only a team can access their secrets. They have to authenticate to do it. I know who's accessing the secrets. So, and I know how often it's rotating. So that's the part that it allows you to do. So yes, auditability is a huge challenge. The other thing that allows you to do is to make your clusters more ephemeral. Clusters break, right? Like we've all watched David Flanagan, aka Raw Code,
Yep.
have a lot of fun at people's expense, right?
Or blue green, right? On purpose, on doing blue green.
Yeah, and so clusters break. That's a big value of GitOps, right? Why don't we just write our manifests to the API server? Because we want to have some place where if the bad thing happens, or really when, and we need to rebuild a cluster quickly, those manifests all exist outside of etcd. And so the secret managers give you that, but in a way that's actually designed to manage secrets, whereas GitOps gives you that in a way that's designed to manage manifests. Does that was I able to explain that?
Yes, actually, yeah, it answers part of the concerns, but also, I mean, we also have config maps which are stored. So basically, it still depends on Kubernetes storage.
Yep.
And also, if also talking about breaking cluster, we also sometimes, not sometimes, we also have databases now with on Kubernetes. So also that's also it still depends on Kubernetes. So yeah, that's why the things which is keeping Kubernetes ephemeral true, but also it's now also worth considering for like stateful set deployment.
When you stateful set, you don't deploy the cluster. One use case that I can talk at least for the company that I work with, is AWS Cloud, is that like deploying all these configurations is massive, right? You have like 5,000 teams and then sharing all these clusters. So the config maps, you want to deploy with GitOps, the secrets, you can use QC to apply from a CI/CD system, right? But then like the rotation, you have to do it every 30 days. That systems like, for example, Secret Manager, I don't know if Vault does it. It automatically handles the rotation and generates a new secret. So that's a place where external manager, I see it as a GitOps. Like if you, like for example, you can have Flux connecting to S3 files, YAML files, and put it into etcd. External secret manager, I see it the same way. It's just syncing. It's syncing the keys or the passwords that are in Vault or Secret Manager, AWS Secret Manager, that when you create a database, they automatically rotate. You can rotate other things in there, that other systems can access those secrets. It's not just Kubernetes app. It's other people using the same secret somewhere else to access the API. But that's the syncing. Like you don't, that's the it's basically automation of like doing the reconciliation between the things that are changing every 30 days. Make sure that if a secret gets changed in AWS Secret Manager, and that secret needs to be used in 15 clusters, boom, that the GitOps or Secret Manager does the sync, if that makes sense. The same thing will happen with Git. If you have a config map that is for 15 clusters and 2 apps and every cluster, then you update it in one place and does the sync. So it's external secret is, I think it's very useful for that. The only thing that I see in the field is people saying, but they're in etcd, and we go to square one. Like, it depends where that etcd is, who's managing it. So for example, in a cloud provider, we have a checkbox that says encrypted with KMS and bring your own key. And I like, for some folks, that's just a checkbox and they can go with it. Other folks, they don't have a way to protect that etcd, so they get nervous. But like Mark said, other strategy is like rotates as fast as possible. Scott, do you have something to add?
I was going to say you hit it with the GitOps, I think, Carlos. So what I've run into is, let's just say Nginx Ingress, right? Got to have your certificates in there. You don't put those in Git, right? But I want to automate that deployment, so I need that somewhere. And that's where something like external secrets comes in to really help. Or use like a Helm, right? It's not easy to modify a Helm template from a vendor, we'll say, for an example, to suddenly work with Vault. Or else you're updating it every time you get new Helm charts. So the external secrets, it's just a great add-on for that. More of a compliance thing and just best practices, right? You just don't put your certificate in there. Not your private, at least, right? Public, but yeah, it gives you that extra layer.
Yep. Aniket, you have a question? You have your hand raised? I think you're speaking, but we're not listening. I see you're... Maybe there's having mic problems.
Weird.
You can type it in the chat if you want also. Looking on time here.
So, I mean, one of the main points I want to bring up when it comes to external secrets and the security of the secret is there's a blog post that I linked to in the chapter, right? I think right there, plain secrets are fine. And this was the best I've seen articulated as to why it's okay to use the secrets API. So before I talked about the different perspectives in the book between Scott being from a systems background, me being from an applications background, I write an application. I'm a software vendor. I sell software for a living. I can't write every single secrets manager, right? Like I can't write to Vault, to AWS, to Azure, to Google, to Pulumi, right? To Keylist, to all these different secret managers. They all have their APIs. And for me to have to write to each of those, it would never work. So I write to the secrets API. Now, it'd be awesome if Kubernetes had some kind of pass-through secrets API, but
why a pass-through? Can you elaborate on that?
Well, it would be great if there was a kind of common, lowest common denominator secrets API that I could say, hey, I need this secret. Here's the API. And then there's a backend that says, okay, I'm going to go get it from AKS, or I'm going to go get, as opposed to the Kubernetes secrets API. That would avoid storing it inside of etcd. But there are scalability questions with that, and it's never going to happen.
And you covered this in the book.
but they'll never build into Kubernetes.
I think you covered this in the book. You talking is that similar to the CSI driver?
So CSI is
That's an
very
API.
similar. It's an API, but the CSI driver is a combination of the sidecar and the uh, external secret operator in a way. So the CSI will generate a volume that will store your secret data. Like it won't inject environment variables, but create the volume that is attached to your pod. Um, the it also has the ability to sync secrets into etcd the same way the external secret operator does. So it's like the two projects combined. I find the external secret operator is much easier to
Sure.
use.
Yeah.
I like using it a lot more. I've got a couple of customers and deployments I work on where we went with CSI because external secret operator was still very new and wasn't quite ready for prime time yet. And it's definitely on my list to go back and replace those with external secret operator. It's just a lot more wieldy than the CSI.
So there's a secret provider class that will
Yeah,
create a secret in etcd. I learned
yeah,
something new today. I was not aware
yeah. So,
of
so
this
the
use
way
case.
the CSI works is you create a secret provider class. That's the equivalent of inside of ESO the secret store or cluster secret store object.
I
And
see.
then you define a secret, an external secret, which is the also in the secret class. That that's those two objects combined. That then generates the ability to mount a secret. So in order to sync a secret into etcd, what you actually have to do is generate a pod that mounts the secret, and then CSI will generate a secret object off of that. So where I use
I
this
see.
as a stand-in for ESO, I actually have a pause container that mounts the secrets to trigger the synchronization into etcd. It's a little kludgy.
Okay, but yeah, this one is another avenue, and I have clients using this in production with like I mentioned in AWS we have AWS Secret Manager, and is for people that for some reason they cannot use external secret operator for whatever reason, or they don't want to have the things in that CD. And I guess it's the same aspect as like the having the secrets in a file for the app, but they're not touching etcd, and that's the sidecar methodology to Vault, or to, I'm guessing there's other projects of vendors that do this. So this is a CSI where the kubelet kind of does the work. The kubelet is the one that is going to talk to, in this case, is authenticated with either secret manager, get the secret, and then insert it as a volume in here, and never touches etcd. And it's a similar thing like Scott said, right? So someone can go into the host SSH, find the container, find the layer, and then boom, the files uh, are there. I believe. Is that true? How the CSI works? Is it same process of using the file, or
Yep.
is it stored differently, like the TMPFS or something like that? I guess
I
it's a
don't
layer.
know. I don't remember that particular detail. I just know that there is some. One of the goals of CSI is to really lock down that volume mount, and to make it easier to, like, if you have node level access, to not be able to get there. I don't remember the particulars though.
Yeah, have you seen this, Scott, in the field? CSI used that much?
I haven't, but it's been talked about a lot more, to be honest, Carlos. I haven't seen it in a lot of production right now.
I think I joined my organization 2 years ago. 2 years ago, this is the one that everybody pointed to, and then lately with the, I guess, DevOps is dead and IDP, ESO have become like everywhere I look at. Like people want to try it. They're trying to use it. in the project that I work, an open source Canoe with certain certain customers and clients like Adobe and such, and other customers. It comes up a lot because it's a very, like Mark says, very easy API, very simple. It's like GitOps with a backend that is a secret thing, right? A database that is a secret. And one of the things, I don't know if you know, just to end a little bit, is I've seen, or I learned, I think it was last week, that you can push secrets with external secret manager. So for example, if you are generating or running a database in Kubernetes or whatever, you generate the secrets there, and then there's a push secret object in external secret that will push it back to external secret operator or Vault or those things, and then it get populated to my other 3 clusters. So that's how I can, like, the secret can like be born in one cluster and then push out. Have you seen that use case of like the need to create clusters in Kubernetes because the thing that you're running is in Kubernetes, and then how do I get people the secrets, right? Have you seen that use case of the need to push secrets out?
I can give you one use case as an example. When you install Open Unison, we generate a lot of keys.
See?
And you know, the one of the challenges that we often run into is if you want to then externalize those keys, you got to get them into Vault. And so the ability to make that kind of two-way, where we say, okay, you know, today the way we have it set up is it's only one way. So you set it up and then you move the secrets into Vault and then reconfigure everything to talk to Vault. But yeah, that would be as a vendor, that would actually, if I could build that into the installation workflow, that would actually be really great. That would make implementations a lot easier.
Yeah, so you can use the push secret, create your secrets in Unison, and then tell ESO, hey, sync my secrets back to Vault, right? And that's how you do your seed or transferring secret, right? That get born in an installation. Like that's exactly the thing. Like you're running some software that you're going to provide. It could be Kafka, right? Or it could be whatever service that you're going to provide in that Kubernetes cluster, and you're going to be rotating secrets. So how do I make the secrets available everywhere, right? Pushes to somewhere. This is the use case that I've seen lately. And one more thing before we end, we're at the end. I think there was a PR already open. And you can push, you can put config maps. So if you have config maps, values in config maps that you want to push up, you can do it. The thing that I'm waiting for, there's a PR open and they're looking into it to sync config maps. Like you have things that maybe not secret, but it's like the URL with the secret or some metadata that needs to be in the config map because you don't want to change the configuration. Then external secret operator syncing secret, but also config maps. Something that came up lately, and then there's a PR, there's an activity in the pull request. I can put it in the notes. We're out of time, Mark and Scott. Appreciate your time. I don't know if you will be able to make it in all the 3 sessions, but this is a 4-part going over your books, which I think I've been enjoying so far. Not done yet, but how many pages there are?
It's
600 something. It's almost 700 pages.
Okay, but at least chapter 8 went very fast with me reading it. So I think I'll finish it completely and then give you a big review in Amazon afterwards. Any parting words? Are you guys excited about these sessions? Are you going to come? I'm just trying to convince you to come if you're available.
Oh, I'll definitely
be
be
here.
Please come if you can.
Oh, here, Jack.
There's
Jack, any comments, questions, Jack?
Yes, please.
I have lots of comments. I want to give them a next session. We're almost out of time.
Okay, thank you,
I've got
Jack.
Lots of comments. This is spot on for the type of thing I do. Just spot on. Thank you so much for attending. Look forward to see you next week.
Okay.
Yeah. If you're coming, which chapter would you like to do?
I think we're going to do multi-tenant, right?
Which one?
Multi-tenancy, chapter 9.
Oh,
Yes,
the V
chapter
cluster.
9,
The V cluster?
multi-tenancy, and a lot of people are asking me. Actually, I work about V cluster of NKS, so I need to give prescriptive guidance, and there needs to be enterprise ready. So I want to get your opinion around that, and also like how to do multi-tenancy and what that means, right? Soft versus hard, and managing as a service, like namespace as a service or tenant as a service. Okay, we'll see you folks. Thank you for everyone that came. Tell your Kubernetes friends. Get the book. I really recommend get the book. I'm reading it into the I bought it through Pack, so now I have the web version, and you get the ebook, and it's half price, I believe. I got a half price, so worth getting it to have a conversation next week. Okay, see you folks next week, and keep in touch. And we're in Slack, so comment there, ask questions. If you get something running, tell Mark and Scott in Slack that you got something running. I think it's just an Ubuntu server. All the instructions are there, and the GitHub is there.
All automated. We've written scripts for basically everything.
Yep.
And documented them mostly inline, regardless of people. We had a lot of that in the book before. We took the code out
Yes.
to put more geek talk in.
Yeah,
So,
I think I'll share the repo. I think I did, but I'll share the repo in Slack. I was looking into chapter 2. I think it was setting up the CAN cluster.
oh, yep.
Okay, see you folks.
Thanks,
Awesome.
everybody.
Thank
everybody
you.
next week.
Awesome session. Have a great
Thank you.
weekend, everybody.
Have a good weekend,
Bye.
everyone.